Okay, continuing on in section 7 or 11.8. This is number 7. Same command in the problem is find the radius of convergence and the interval. Okay, so we'll proceed the same way as we did before. The x here, I recognize that 0 makes that convergent. Whatever makes what's in the power here, you have x to the n, so whatever makes that x 0, for instance, if it was x minus 2 to the n, I would say that 2 would be the center point, but since it's x to the n, we're thinking that is x minus 0 to the n, so 0 is the center. Okay, so these are not part of the problem. Okay, so the center is 0. What I want to do now is find the radius, so I focus in on the 1 over n factorial part, and I take the limit of an plus 1 over an. That's equal to the limit as n goes to infinity of 1 over n plus 1 factorial over 1 over n factorial. That's the same as n factorial over n plus 1 factorial. And that's equal to the limit as n goes to infinity of the n plus 1 here, that's n plus 1 times n factorial. If you just take off the first term, then n factorial is what's remaining. So those cancel. So this is equal to 1 over n plus 1. This is equal to n factorial over n plus 1 times n factorial. So those cancel, and you just get 1 over n plus 1. That limit is 0. So what did we say about radius? The radius is equal to 1 over L, where this is equal to L. So I have 1 over 0, so that's infinity. Okay, so we had this center point of 0, and now the radius is infinity, so my interval is from minus infinity to infinity. And no need to check the endpoints because of the infinities are the endpoints. Okay. So continue on. Okay, let's look at number 10. Number 10 is the sum of 10 to the n x to the n over n cubed. Okay, same procedure. Find the radius and the interval. The center point here is 0 because of the x. And now I'm going to focus in on this part, the 10 to the n over n cubed, to find the radius. So remember, radius is 1 over L, where L is equal to the limit as n goes to infinity of an plus 1 over an. So in this case, we're talking about limit as n goes to infinity. I have 10 to the n plus 1 over n plus 1 cubed, and then I'm going to divide by this, which is the same as multiplying by the reciprocal. So I'm going to multiply by n cubed over 10 to the n. Okay, that 10 to the n cancels with almost all of that. It just leaves a 10 on the top. So this is the limit as n goes to infinity. I have 10 times n cubed over n plus 1 cubed. Now, if I were to multiply this out, it would have an n cubed as its first term, and the coefficients in front would be 1 over 1. The highest power on the top and on the bottom is n cubed, so I really only have to find the coefficients, which are 1. So this limit, this goes to 1, so I have 10 times 1, which is 10. Okay, so we found that the limit was 10, so the radius is 1 over 10. The center point was 0, so we're going to go to the right 1 1/10, and to the left, negative 1/10. Okay, so that's the potential interval. Now I need to check the endpoints. So x equals negative 1/10. I have the series 10 to the n, negative 1/10 to the n, over n cubed. Okay, so what happens there? The 10 to the n's cancel, and I end up with negative 1 to the n over n cubed. Okay, and this converges. Okay, it's an alternating series. It's a p series. P series in general converge if the p is greater than 1. So it converges by the alternating series test, if you like. Okay, and now let's check the next endpoint. That's x equals positive 1/10. That gives us the series of 10 to the n, 1/10 to the n, that's the x, over n cubed. These cancel, and you just get the sum of 1 over n cubed, which converges since p is greater than 1, the p series. Okay, so what we have is their final endpoints are calculated, and our interval is from negative 1/10 to 1/10, and including the endpoints. Okay, there's your final interval, and the radius is 1/10. Okay, I'll do one more here. Let's do number 15. This is one where the center point has been moved a little bit. So I keep talking about this center point, but all of them have been the same so far. Okay, so here, same thing, I want to find the radius and I want to find the interval, but here my center point is 2, and the way I determine that is whatever makes that 0, because after all, if x is equal to 2, this is 0 to the nth power, which is 0, and so I'm just adding up 0, so it's definitely going to converge for x equals 2. The question is, are there any other values? And for that, I need to find the radius. So remember, the radius is 1 over L, where L is equal to the limit as n goes to infinity of an plus 1 over an. That's the limit as n goes to infinity. Okay, the an it's just that 1 over n squared plus 1. So I have an is 1 over n plus 1 squared plus 1. And then I'm dividing by an, which is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal there. And that gives me limit as n goes to infinity of n squared plus 1 over n plus 1 squared plus 1. And again, that goes to 1 because both powers are the same. The highest power is n squared, and the coefficient in front of that is 1. If I were to multiply this out, the very first term would be n squared, and that's all I care about. And the number in front of that is a 1. The number in front of the top one is a 1. Put them together, the limit is 1. Okay, so the radius is 1 over 1, 1 over L, which is 1 over 1. Okay, so we get 1 there, and the center point was 2. So now I'm going to go to 3 and back to 1. So there's my interval, potentially, but I need to check the endpoints. So when x equals 1, I have the series of 1 minus 2 to the n over n squared plus 1. Which is the series, this is just negative 1 to the n over n squared plus 1. This converges. by the alternating series. Test. Okay, and then let's check the other endpoint, x equals -1. Then that gives me, we checked x equals 1, now I need to check x equals 3, that's the other endpoint. X equals 3, so now I have a series of 3 minus 2 over n squared plus 1. And of course that's equal to I just have 1 to the n, which is just 1. I don't have to have the n there. This one was on the midterm. This converges by the integral test. That's equal to inverse tangent, but also it converges by limit comparison with 1 over n squared. If you like, I'll do that for you real quick. The limit comparison is limit as n goes to infinity